Hi, I'm Lea. Here's a fun fact you may not know about me. I'm originally from Greece, and specifically from the island of Lesbos, which technically makes me geographically lesbian, probably the first you'll ever meet. Seriously, that's what the word means. The other meaning came later. Originally, it meant somebody from Lesbos. In other news, I like making stuff. I've started a lot of open source projects. You might have used some of them. Here are some. All of them are on my GitHub profile. I'm an invited expert in the CSS working group. There's me. The others are, this is a photo of all the active CSS working group members. And I've written a book. It's called CSS Secrets. It's translated in a number of languages, including Russian. So there's the Russian version. And as my day job, I'm a researcher at MIT. I do research on trying to make web programming easier, and I also teach user interface design. Mavo is the result of my research for the last 3 years. It's an open source project that extends the syntax of HTML for defining web applications without JavaScript or backend coding. So let's get back to the topic of today's presentation. It's called Even More CSS Secrets, and you might wonder, even more? Like, more than what? So this is actually a sequel, and the first version, with completely different secrets, obviously, came in 2011, 2012. I felt that the format of giving a talk that is about one thing was very restrictive, because I'm excited about way too many things. So I used to give this talk called CSS3 Secrets around 2011 to 2012. And these were the 10 secrets that it was about. By now, it's been over 6 years since that talk, so you may know most of them, or maybe not. And then came a first sequel, more CSS Secrets, 2012 to 2013, which was another 10 things, which maybe today you know or not. And then for a number of years, I did more focused talks. I did a talk about border radius, a talk about colors, a talk about pie charts. And then I decided that I wanted to do another talk, another CSS Secrets talk, because again, there's too many things to be excited about. So, without further ado, let's start with the first secret, cut out text. I'm sure you've noticed, well, maybe not. In the cover of this talk, there was cut out text where you can see a solid background, but the text is actually transparent and you can see what's behind it. So how can we do that in CSS? It's actually pretty simple. And it uses this thing called blending modes. How many of you have heard about blending modes? Excellent. So if the background is black, then we can do cutout text by setting the color to white and then specifying mix blend mode multiply. And at this point, you might be wondering, okay, I can learn this line, but why? Why does it work? If I didn't tell you why it works, then this would be kind of pointless, right? So I made this little app, which you can play with after the talk, because the slides are online. And you can enter any CSS color here. Maybe yellow is not a good idea. Let's say green, whatever. And you can select the blending mode of these two. It doesn't have all of them. And you can see not only what's the result of the blending, but also what's the math behind it. So let's try a few colors. And let's go back to an RGB color, just because it's more interesting that way, and it makes more sense. So if I so notice that the math behind the multiply blending mode is actually literally a multiplication. It takes the RGB components of the first color, the RGB components of the second color, in a scale of 1 to 100%, and it just multiplies them. For example, when you have yellow, and you multiply it with this purple that's behind, you can see here that 50% multiplied by 100% is 50%, and so on. And this is how we get this kind of like dark red that's in between. So because of the way the math works, multiply has this special behavior with black and white, which we took advantage of. So if we have white, we always get the color that's behind. We always get the other color, because we're just multiplying everything by 100%. If we have black, we're multiplying everything by 0%, so we always get black. So in practice, when it comes to our example, when we specified black, we get black, which is why we can see the black background. And when we get white, we always get the other color, which is why we can see what's behind the element. And similarly, there's another blending mode called screen, which is sort of the opposite of multiply in a way. So let's remove the blending mode for now and specify white here and black here. And this is what we do if we want white background and cutout text. And the reason this works is if we go to the math for screen, it's a little more complicated. But let me zoom out and see if that will work. Yes. So as you can see, let me pick a slightly different color so that we can see it better. So as we can see, the math for screen is a little more complicated, but essentially it ends up having the opposite result for white and black. And we'll see why. So when we specify black, notice that this is 100%, so because it's 100% minus 0. So anything multiplied by 100% remains the same. And then here we have 100% minus 100% and plus the color component of the first color. So essentially, when we screen with black, we get the color we have behind. And when we screen with white, we always get white. Why? Because the second component that we're multiplying with becomes 0, like 100% minus 100%, 0. So essentially, we're getting 100% for each component, for each color. So this is why screen works for cutout text if the background is white. Now you might be wondering, okay, how do I do cutout text if I have a different background color that is neither white nor black? So I'm afraid I don't know the answer to that. Maybe you can find it. Maybe you can play with blending modes and you can find a different blending mode that works for a different color. I've looked and I can't find it. For example, if we use multiply and we use white and say instead of black, we use a different color here like F06, you can see that we do get cutout text, but our background is also sort of blended. So it sort of works, but not quite. It works exactly as we want for black and white, though. And what's best is that it degrades very gracefully. We don't even need to provide a fallback, because if blend mode is not supported, this is what we get. It's perfectly readable text. The browser support for blending modes is pretty good, not ideal, but what is ideal at this point? And like I mentioned, it has a fallback. You can see in all my Can I Use slides, I've imported the usage data for Russia. So you can see here, I'm not sure if you can see it well, but the first number is how many users in Russia will have this feature and how many users in general in the world. So it's 86% globally and 78% for Russia, which I think is a pretty good percentage, especially for an effect that degrades gracefully. So these are the takeaways from the first secret. With multiply blend mode, black is cut out and white is opaque. With screen blend mode, white is cut out and black is opaque. It's an open question how we do this effect for other colors. The second secret is how do we use characters as images? Look at the background of this slide. These are not images. This is text that I've used as an image. There is no actual image file being loaded. It's just my actual emojis and my actual number glyph and the actual to glyph. So how can somebody do that? So let's take a minute to look at this background. It's a data URI specifying an SVG file, and the SVG just defines a red circle. it might become more interesting if I make it smaller. And you might have seen data URIs like this before, and maybe you've been told that you need to URL encode a ton of characters. You actually don't. There are very few characters that you actually need to escape. Most notably, that is weird. Okay, I don't know why this didn't work at first. Most notably, these characters, and not even those in most browsers today. So these are the reserved characters according to the URL spec, the RFC 3986. And as you'll see, even those characters don't need to be escaped in most browsers. So the main thing is that when you use multiple lines in a URL in your CSS, you have to escape the line breaks. If you don't escape the line breaks, terrible things happen. If I go here and remove the line break, my entire image breaks. So always remember to escape the line breaks. So like I said, this just defines a circle, and the circle is not very interesting. I can already do a circle with a radial gradient. But if I'm using SVG, I can also do text. And let's give it a baseline. And now you see I'm starting to have tiny, tiny text here, but I can make it bigger. So I've defined here that my coordinate system is 100 by 100 via the SVG view box. So if I define my font size as 90 or even 100, the text becomes almost as big as my background, so I can see it. And A is not super interesting, but this gives us the full power of emojis. And who doesn't want emojis in their backgrounds? And what's even better is that since this is an SVG, it supports anything that an SVG supports, including style elements with whatever style elements usually have, such as animations. So maybe you see where this is going. And I can add a style attribute here. And let's make it infinite and alternate so that it loops forever. And actually, you know what? Maybe it's nicer like this. No, I prefer it like that. So as you can see now, not only I have an SVG there, it's an animated SVG, and it's all inside my CSS. And I mean, theoretically, you could have an SVG data URI inside that style element, which is inside a data URI. So there's a lot of inception there. Kind of like Russian dolls, like Matryoshka, I think they're called. And similarly, I've used this trick to have a meter with stars. And the stars are actually Unicode star characters. And you can see that I can change this, and it just works. I don't have to use images. I can specify like any number here, and it just works. And this is the CSS. Yes, there is a WebKit pseudo element there, but in real life, you would also use the Moz pseudo element and the Edge pseudo element. Every browser has pseudo elements for this. It's a little repetitive, but if you use Sass, you could also assign it to a variable. Actually, no, a CSS variable would also work. And the best thing is that this gives me the full power of Unicode. I don't have to be restricted to stars. Instead of stars, I could use... Come on. Why? Damn it. Yes, instead of stars, I can use chocolate ice cream. And this works just the same. And it also shows any value you want to show in that meter. So, takeaways from here. You can turn glyphs into animated images with SVG data URIs, and you can use this trick to style meters with discrete icons. And you can also do a ton of other things, but like, we have limited time. However, Another cool thing you can do with SVG data URIs is fancy borders. Take a look at this and try to think how you would do this kind of border in CSS. Not only it's animated, not only does it have custom dashes, but it actually has a gradient on it. And CSS borders don't support any of these things. They just give us a dashed keyword, and whatever the browser renders it as, that's it, and only solid colors. And yes, there's a border image, but it can't property, but it can't do this. So how do we do that? First, let's come up with an SVG to do the marching ants effect. So here I have a simple a rectangle SVG with a stroke width of 4, and no fill. And here is a cool SVG. Whoops. Here is a cool SVG property called stroke dash array. Oh, come on. And this allows us to do custom dashed borders, well, strokes as SVG calls them, and we can customize the length of the dashes and the length of the gaps. So if I specify 10 pixels, it means I have dashes that are 10 pixels and gaps that are 10 pixels. But I can make my gaps smaller, like 5 pixels. So this is already much cooler than what CSS borders allow us to do. But there's more. So there's also a stroke dash offset property that lets us move where the dashes start. And look at how as I'm reducing this property, it looks like the border is animated. And what's more is that minus 15 pixels basically gets us to the same point we started. Look, if I make this 0, there's no change. So I can take advantage of this and make a cool animation that will let me create a marching ants border that constantly animates and never stops. So let's say 2 stroke dash offset minus 15 pixels. And actually, I don't need this because 0 is the default value. But we will add the animation, marching ants, 1 second, infinite. So notice that now it's animating, and it is animating smoothly, but it does seem that it's sort of moving and stopping, and then moving and stopping. This is because the default animation timing function is not linear, it's ease, which means it accelerates, and then like there is acceleration happening. It's not constant speed. So I can add the linear keyword, and now I get exactly what I wanted. And I can even make it like faster or slower as I please. But what use is this SVG by itself? Well, I can copy this. Whoops. I can copy this into a data URI. So here I have a div with a class of unicorn and then a rule. I have my data URI ready because you've seen that already. And I can paste my SVG here, escape the ends of the lines, and you can see that I already got this awesome border. And I can change the text, and it just works. The border stays the same thickness. It works just as I would expect a normal CSS border to work. But SVG strokes can do a lot more cool things. So here I have another rectangle with a thicker stroke. So in SVG, strokes are not restricted to simple solid colors. I can have strokes that are gradients. The syntax is different than CSS gradients, much more wordy. There's an entire element called linear gradient. And then inside it, there are stop elements with stop color attributes. And more stop elements with stop color attributes. Let's make this blue, AC. And then there's an offset attribute to make it go at the end. And then I have to give my gradient an ID, let's say gradient. And now I go here at the stroke and say URL gradient, and my stroke already has a gradient. And wouldn't it look better if the gradient was diagonal? So I can do that by an attribute. Yes, the syntax is very unwieldy, but it does very cool things. And yes, the transform's different than in CSS. If I specify degrees, it doesn't work because SVG transforms came earlier. So they have a slightly different syntax. So there are a few hoops to jump through with SVG, but the result is worth it, I think. So let's copy this inside a data URI that I have ready here. And let's escape the lines. And now look, I have an awesome border. You might notice that the text goes over the border, which is less awesome. This is because, ultimately, in the end of the day, it's a background. But we can fix that with a padding. And notice that we only needed half the padding. Our stroke width is 40 pixels, and what we actually see is 20 pixels. Why does that happen? This happens because, actually, when you draw a stroke on an SVG shape, half of the stroke is inside and half of the stroke is outside, which is almost never what you want. So there's a new property that will allow us to control where that goes. I think it's stroke offset. Chris? Stroke offset? Yeah, so there's a new stroke offset property planned, but no browser supports it yet. Because browsers think that we don't really care about SVG. Browsers think that developers aren't really interested in new SVG features. So if you think that SVG is cool, and I think that SVG allows us to do a ton of cool things, then you should tweet to browsers and let them know that we want cool SVG features. We care about SVG. Because that's how browsers prioritize what to work on based on what developers want. So, takeaways from the third secret. SVGs with no view box. Notice that I had no view box in my data URI. Spread to cover the entire area, but strokes stay the same width. And we can apply this. You can use this to apply fancy SVG strokes to our HTML elements. And there are a ton of cool things we can do with SVG strokes. This is just the beginning. So the fourth secret is about line headings. Don't let the animation distract you. By line headings, I just mean headings that have lines on each side of them, and they adapt to whatever text the heading contains, which is a very common effect. I just like the animation for this cover, but the effect is not actually about the animation. So here we have a simple heading. It has content editable, so I can edit it later and show you that it's indeed flexible. And here I have some basic CSS. I'm going to apply a background to the heading so I can see what I'm doing. And then here I have two pseudo elements, before and after, which I will activate by using an empty content attribute. I'm also going to give them a background so that I can see what I'm doing. Actually, let's give them some content too. And now, let's make the heading full width. And we want to make these stretch to cover the entire width of the heading, except the area occupied by the actual heading text. So, Flexbox to the rescue. And then I'm going to give flex 1 to my pseudo elements. So you can see where this is going already. Let me remove the A, which we didn't really want. And I can now remove this background. And I will give this a smaller height, because we want lines, remember? And let's use the align items attribute, which aligns Flexbox items, and make it center. So we're already there, basically. Let's give it a little bit of margin to make it prettier. So there it is. And you can see that it's pretty flexible. And when the text becomes longer, the lines just disappear, which I think makes total sense. So we don't even have to account for what happens when the text is too long, because it just magically works. And we can do a lot of effects that way. Let's say maybe instead of a solid color, we wanted to have a gradient. Why not? So we can do something like this. And now we have a gradient. Or maybe because this is kind of hideous, let's be honest. So instead, we could also do other effects, like apply a border. And then border width, top 0.1 then 0. And you can see that's also a very common effect, like having a double line. So takeaways from this: text nodes and pseudo elements can be flex children and work just like any other flex children. Because essentially pseudo elements are inside the element, but in the beginning or end. So the fifth secret is about accessible CSS menus. How many of you have done a pop-up menu like this with CSS at some point, either as an exercise or for a client or whatever? Quite a few. It's a pretty common thing to do with CSS. However, until today, when we did these menus with CSS, they are inaccessible to keyboard users. And often we forget to write the JavaScript to make them keyboard accessible, so people that can't use a mouse can't use our menus. And why am I saying this? So here we have a menu. It's just a series of nested lists with A elements for the menu items. I've styled it to look as a menu. Most of the code for styling is hidden because it's not relevant to this, like you know how to do a background orange. The only relevant code is this, that by default the child ULs are hidden, but when I hover, I give them display initial to show them. However, this means that when I'm using keyboard focus, even though I can tab through each menu item, like I'm pressing tab right now and another tab, but notice that unless I'm already hovering over the parent menu item, I can't actually access the sub-menus with the keyboard. When I tab, it just goes to the next item, because things hidden with display none are outside the tabbing order. And there's no way, until today, there was no way to display them with CSS, because there was no way to say, I want to target this UL if it has focus inside it. The best thing we could hope for was to do something like nav, if the A item has focus, then the UL next to it should be displayed. And now, if the parent item is focused, the submenu is always showing. It doesn't go away when I move my mouse away. But when I try to tab through the actual submenu, I'm going to press tab now, it disappears. So that's kind of useless, because it's just a teaser. It's like it's telling the keyboard user, hey, there's this submenu here, but you can't actually use it, sorry. So how can we deal with this today without JavaScript? There is a new pseudo class called focus within, which is basically like a very, very, very special case of a parent selector. It says, focus within matches elements that not only have focus, but also if one of their children has focus. So how does this work? It's basically the same as the selector above, except instead of hover, I'm going to say focus within. And now, I can tab through the submenus just fine. Tab, 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 tab. It just works. And Focus Within has pretty decent browser support. I mean, it's supported by 72% of users, and almost 72% in Russia as well. So the takeaways from this is that focus within and accessibility equals love. And also, I did not mention this, but target within is also coming, which will be very useful for single-page websites, because we already use target to like open items based on the URL hash, but we couldn't target things that contain this. So the sixth secret, and probably possibly my favorite, is about using variable fonts to create non-variable strokes, as you can see in this heading. So how many of you have heard of variable fonts? Probably the ones that were in Chris Lilly's talk earlier today? And maybe others? OK. Some of you have not heard of variable fonts. So let's quickly go over what variable fonts are. So remember how many years ago, decades ago, many of you might not have even been doing any programming back then. But many years ago, when our fonts weren't actually vector-based. Like 20 years ago or more, fonts were bitmap based. Every character had to, every character size had to be drawn separately. And at some point, we got vector fonts. And now suddenly we could have all sizes, and there were no restrictions, and we could interpolate and even animate between them, and it was a huge revolution. So, how is this related to variable fonts? I think that variable fonts are an equivalently big revolution. It's taking something that is discrete, and we had to use like all the different sizes that were drawn specifically, and it's making it continuous. So, variable fonts are about having different axes, such as weight, italic, but also custom axes, like, as you'll see some, I'm going to show you some with custom axes. And basically, instead of having only like 9 font weights at best, we can have like hundreds of font weights, and we can animate between them. And it's not just about font weights. It's also about slants, width of the characters. And there is even, later on this website, by the way, is called v-fonts. It has all the variable fonts, pretty much. So if you're interested in variable fonts, you should totally check it out. But later on here, there is an emoji. There's a font with just the poo emoji. And it uses a custom axis to set the height of the hat of this poo emoji. There it is. So it's using a custom axis called cap height. And when you change that axis, the cap grows. I also love the pun here. Cap height in fonts usually means the uppercase height. But here, it's actually the cap of the emoji. So there is syntax in CSS to set all these custom axes, like font variation settings. But the ones that correspond to CSS features, like font weight, we can just use font weight for. It has slightly worse browser support, but we're going to use font weight for this demo. So here, I have a heading with 4 lines, and this is the CSS that includes the font. So the font is called drive variable. It's a variable font by Black Foundry. This one is a commercial font. There are variable fonts that are open as well. This was provided to me by Black Foundry for this demo. Thank you very much if you're watching this. So I've used it here for this heading, and I've adjusted the font sizes of each line so that they are the same. Each line is the same width. But notice something here. Even though every line has exactly the same font weight, it's all 300, the R looks much bolder than the rest of it. And fonts also looks bolder than variable and awesome. The reason for that is that, I mean, if you scale a path, its strokes look bigger. Like, that is how scaling works. If you make A bigger, its strokes will also become bigger. So how could we fix that? We could go in, and because we're using a variable font, we have access to all the numbers. So actually, I'm going to do the 3rd line first, because that's the most egregious. So if this was not a variable font, the best I could hope for would be 200 or 100. But because it's a variable font, I can tune it exactly to the weight I want. And I can stop exactly when it becomes the same stroke as the word awesome underneath it. And similarly here, I can try maybe something like this. Yeah. And I can fine-tune it to exactly the weight that matters, exactly the weight that gives me the effect I want. But you might be thinking now, this is kind of horrible. I would have to like manually adjust the font size and the font weight, and like, what if I need to change the content of this heading? What do I do then? So, how many of you here like maths? Very few hands? Okay, so, how many of you know a concept called regression? Well, hello there. So, regression is when you have a bunch of points, let's say 4 in this figure, then linear regression gives you a line that has the minimum distance from these 4 points. You can see an example here. And because it's a line, it has an equation with like some number multiplied by x plus some other number. And there is also quadratic regression, because as you can see, this line, I mean, it tries. But we have 4 points, and they are quite different. And as you can see, these 4 points are nothing even close to a line. These 4 points, by the way, are not random. They are actually weights and sizes of a different variable font called FF meta. So as you can see, linear regression, it tries its best, but it's pretty far, especially from this point. Like, look at the distance here. Pretty noticeable. So there's also quadratic regression that gives us a second-degree polynomial, which has more chance to fit our points closer because it has more flexibility. It has 3 parameters, 3 numbers. So why is this related to variable fonts? Because basically, this is what we have here. We have a bunch of measurements, and ideally, we want to find an equation that governs these measurements. We know that when the font size is 1em, the font weight is 300 to get the effect we want. And when it's 1.5ems, it's 190. And when it's 2.7ems, the font weight is 90. So we have these three measurements, and that means we can find an equation to give us all the other measurements so that when we change the font size, we automatically get the right font weight. Shall we try that? So, first off, we will need to use CSS variables for the size, because we can't get the value of the font size property, but we can get the value of the size variable, and we will need to have them as pure numbers, because once you have ems, you can only get ems in CSS. You cannot divide them with ems and get a number. So, let's say 1 is a default, and font size, this is just to get back to what we had. Okay. And now, I've made a calculator that calculates linear regression based on Wolfram Alpha. So notice that I already have the first 2 points here. 1 is 300, 1.5 is 190. And I'm going to also add the other point, which was 2.7 and 90. So you can see that this is the line. Actually, I'm going to make this bigger. You can see that this is the line. It's a little far, but maybe it will work okay in practice. So let's try to use this. So our font weight, calc, this will take multiple lines. And this is the equation we got from Wolfram Alpha. So let's change the x with our actual variable. Moment of truth. If I remove the font weights here, what happens? It actually looks pretty close to what I had. So even though the line was pretty far from the points, it's actually not that bad. Even this simple equation, which is just a line. But what happens if I want to change this? This is the actual moment of truth, right? Let's say I wanted to make R awesome 1 line. So obviously I would need to change the font size, maybe to 65 or something. So now we're starting to see that maybe it's not exactly equal. So let's try quadratic regression. Come on, come on, come on, come on. So you can see I thought I had another. I can't. So here we are getting this two-degree equation, which it's kind of a pain to copy because Wolfram Alpha just gives you an image. You know what? I'm going to open this in a new tab and copy it from there. Because there I can actually click plain text and copy it from here. So let's go back. And this is the equation it gave us. OK, let's press enter here, and we're going to multiply size twice. So as you can see, second degree gives us something much closer, even though I never had to put in this point. The point 66 is not part of my data. It's not even within my data. It's outside my data, and it still works. And notice that if I increase this, it works on every size almost. Up to a certain point. If I make it too big, it starts breaking, because a 2-degree polynomial is a parabola, so it actually goes like this. So at some point, we'll start increasing again. So, and this equation is also helpful even for other use cases. So here, we have an acronym where the letters are smaller, because good typography rules tell us that acronyms ideally should be smaller so that they don't attract too much attention. And similarly, we have a superscript. And it looks kind of bad because the superscript is shrinked and the strokes look smaller. And same with the acronym. The strokes look smaller. So we can fix this with exactly the same method. So we can change this to a size variable instead of font size. And do this. And presto. Now the strokes look much more similar to each other than they were before. So, takeaways, the weight axis lets us equalize strokes, and we can use regression to avoid calculating the weight every time. Also, thank you, Black Foundry, for your font. Now, the 7th secret is responsible Flexbox without media queries, just like this heading is showing. So yes, you can use media queries to change FlexFlow, but sometimes you actually want to change it based on the size of the component and not the size of the viewport. And since we don't have element queries, how can we do that? So here I have something like a sort of a media post, a forum post or something, and you can see that the article contains a header and the div class equals post, and this is the CSS that concerns us here. And notice that if I make it smaller, nothing changes, which looks pretty horrible. We can fix that with FlexWrap. And now, in smaller sizes, this happens, which is slightly better, but this kind of looks ugly. Oh, you can't see that. You can't see the background. Let's make it more prominent. Yes, it's horrible, but at least now you can see it. So this is what we had, this is what we got. So this looks kind of horrible, but I can fix it by applying flex. So this fixes the vertical orientation, but it doesn't fix this one because now they are equal, and I really didn't want this. So what can I do? I can go here and apply 999 here. So they're both flexible, but the post is much bigger. So now we almost get what we want, except at this point, this is way too thin, and I did not want this. So I can still specify like a min width, 10 ems, and then I can change at what point the layout flips. So I have like full control, no media queries, and it actually depends on the size of the component when the change happens. So takeaways. Flex sets, flex grow, flex shrink, and flex basis. Essentially, we're specifying one number, so it's flex grow that we're actually specifying. Flex is a shorthand. And it defines how the remaining space is distributed. So as long as we overwrite it, it stretches. And the proportion between 999 and 1 means that the one with 999 stretches pretty much as possible. But the one with flex 1 still stretches when it's vertical. And this is based on the FlexGrow 999 hack by Joran van Hee. You can see his name here. So 8th, auto-flowing grids. And what do I mean by that? Here I have a list of items with classes like cat, male, female, human, female, male, and so on. And I'm going to apply a grid. How many of you have used grid or know about grid? Many more know about grid than have used grid. OK, so we apply grid with display grid. Nothing happens by default. They're still laid out top to bottom. But we can apply grid template columns and say auto, which means they're sized based on the actual contents. And maybe let's say grid gap, this 0.1m. So notice that now it happens in source order. So in whatever source we had in our HTML, this is the order we got. But that's not super useful. We could have done that with multicol. But with grid, we can actually change this however we want. So we can say grid column 1 for human and grid column 2 for cats. And what do we have here? That is probably not what we wanted, right? And the reason for that is that by default, since we're using an automatic grid here, and even though we specified the columns, it's still automatic because we haven't explicitly specified the rows. So because we're using an automatic grid, it flows by row. So when the time comes to insert the humans, it's already underneath. We can change that with grid autoflow column. And now the flow happens by column. And what's best, I can completely change how these work. I can also change how they're ordered. Like, I can make this male and female. And we still get the effect we wanted. We still get them in the places we expected without having to change the HTML at all. And another example of why grid autoflow is great. So here I have a series of images and display grid on the body. I'm going to specify that my columns are 4 columns of 200 pixels each. And in this case, I'm also going to specify the rows, because I want a 4 by 4 grid. And look at what happened here. And that's because the images are still their full size, which we can change by width 100% and height 100%. And now you're shocked because I've committed this cardinal sin of front-end, which is stretching images. But I don't have to suffer the consequences because I can use object fit cover, and now they have their proper ratios and they cover the entire area of the image. So let's make some cats bigger to have a more interesting grid. So I'll take the 3rd one and the 5th one and give them a span, grid column and span 2. Which makes them 2 columns wide, and then grid row and span 2. And oops, what happened here? We have a gap. So how can we avoid the gap? We can still use grid autoflow with the default row layout, but also the keyword dense. And the keyword dense shifts cats, images, grid contents up to fill any holes in the grid. And we can still specify column here, and we just get a different grid. So CSS Grid has pretty decent browser support, actually 87% globally, 77% in Russia. Object Fit, that some of you might not have seen before, has even better browser support, 90%, 92% globally, 81% in Russia. So takeaways, grid autoflow defines the direction autogrids are laid out, the dense keyword prevents holes, and object fit cover prevents image distortion. Super useful and very well supported. Pie charts. So you probably know about gradients, but conic gradients are also coming. And they allow us to create hue wheels, but also if we put 2 color stops in the same position, we can also do pie charts with them. And we can use a CSS variable for where the pie chart is, like this. And we could duplicate it here, but we don't actually need to, because we don't just need 40%. Anything smaller than 40% works. So we can just specify 0 here, and it works with any number. So I can change the number here, and it just works. And I can specify the number even here. So I have almost kind of like a component that I can just change the HTML, and I'm showing a different value in the pie chart. Let's remove it from the inline style for now. And also, because the var function has default values, I can specify a default value and have multiple colors here. So now I have one color. I'm showing one color in the pie chart, one segment. But if I specify 60% here, oh, right, of course, typo. Oh, yeah. So if I specify a different number here with value 2, now I can have multiple. So I can show any number of different values on my pie chart just by changing a few CSS variables. And that also means, you might be wondering, can I animate this as well? Well, kind of. So let's define a keyframe and make value 100%. And let's try to apply this animation. Let's say 1 second infinite. So as you can see, it doesn't really work. It keeps going from one value to the other because the browser doesn't really know how to animate our value variable. But I can use this new JavaScript to specify exactly where, exactly how it's animated. I can say that this is a percentage. And if I run this, now you can see that I actually have an animation. So this will allow us to animate CSS variables, which opens up a ton of cool cases. Unfortunately, but conic gradients are going to be enabled in Chrome 69. They were recently shipped, but it takes a while. They will be in Canary soon and Chrome 69. And even more unfortunately, CSS.register property is only supported behind a flag in Chrome. But hey, we can be excited about future things as well, right? So conic gradients are coming. Also, something I didn't really elaborate on, 2 color stop positions for bands of colors are coming as well. Notice that I used color stops with 2 positions. And a color stop position of 0 creates hard lines regardless of the previous position. And CSS.register property will allow us to animate custom properties. Can't wait. And lastly, Descendant grid items. What do I mean by that? So look at this form. It has 2 labels, 2 inputs inside them, and I want to display it as a grid. So you know the drill, display grid, and I want 2 columns, so... Sorry? Oh, thank you. I would have been very puzzled. So grid template columns. I want the first column to adjust to the contents, so auto, and the rest of the space should be distributed to the second column. And notice that I totally don't get what I expect. But the browser just did what I told the browser to do. I have two children of the form element, and it arranged these 2 elements in 2 columns. So it's not wrong. It's exactly what I told it to do, but it's not what I wanted, as often happens when coding. So what can I do? Until recently, not much. But there is this new display value called display contents, which basically tells the browser, treat this element as if it didn't exist in terms of CSS. Like I can't do anything to it anymore. Now, I can't even apply a border to it. See, nothing works. It's as if it's completely removed, which has the benefit of making its children grid items. So now my grid just works. And another good use of display contents is on website layouts. If you want, for example, to have a header element, and you want the children of the header element to take part of the page grid, you can just apply display contents to the header. So display contents has not fantastic browser support, but decent. And it's coming, like it's 64%, basically 2 out of 3 users. Display contents allows us to make descendants, flex, or grid children. And as we've seen previously, text nodes are flex and grid children too. So before I finish, I want your feedback about which secrets you liked best and which secrets taught you something, which ones you knew already. So go to yelkey.com/entire. I promise it will take a minute. It's like literally a list of secrets, and you just click radio buttons. So, spasiba, thank you very much. And I have stickers.